Section 1.2 is on the basics of functions and their graphs. Okay, the first thing we're going to look at is something called a relation, and that's just a set of ordered pairs. Every relation will have a domain and a range. Okay, we will be talking about domain and range a lot in the future chapters. The domain is always associated with your x coordinates, and the range is always associated with your y coordinates. And notice here I say that the domain and the range are both sets. Okay, they're always sets of numbers. Every relation will have a domain and a range. Okay, we have some relations that are also considered to be functions. A function is a relation in which each element of the domain corresponds to exactly one element of the range. No x value can correspond to more than one y value. Sometimes we think about our x values as being our input. So if I have one certain input, we have to have one output, which is our range. So when you're looking at a set of ordered pairs, like we have on number 3, this says determine whether a relation is a function. When you're looking at the ordered pairs, you just want to make sure that every x value is different. Okay, 1 corresponds to 6, 2 corresponds to 6, 3 corresponds to 8, 4 corresponds to 9. This would be an example of a function because every x value is different. Okay, it does not matter that we have two y values the same. That's okay. It's just the x values. Okay, then if I look at part B, 6 corresponds to 1, 6 corresponds to 2, 8 corresponds to 3, 9 corresponds to 4. Okay, this is not a function because I have two of the same x values that have different y coordinates. Okay, so that would be an example of a relation that's not a function. Sometimes you'll only have the equation and not the set of points, like on number 4, where it says determine whether each equation defines y as a function of x. So in this case, what you're going to have to do is solve the equation for y. So if I take 2x plus y equals 6 and solve it for y, I would have y equals negative 2x plus 6. And then I want to look to see if I put in a value for x, will I get a unique value for y? Okay, this is an example of a linear equation. And all of our linear equations are functions except for the horizontal line, the vertical line. But here I could, just think about if I plugged in a value for x, let's say I plug in a 0, then I'm going to get y equals 6. Okay, that's the only answer I'm going to get. When I plug in a 0, I'm always going to get just a 6. Okay, or if I plug in a 1, I would get a unique value. So that would make this a function. If you look at part B, x squared plus y squared equals 1. If I solve this for y squared, I would have negative x squared plus 1. Take the square root of both sides, and that would leave me with y equals plus or minus the square root of negative x squared plus 1. Okay, remember when you take the square root, you always have what we call the principal square root, which is the positive, and then the negative. So that means if I plug a value in here for x, I'm going to get a positive answer and a negative answer. So I'm going to have two x values that would correspond to the same y value. So this would be an example of an equation that's not a function. So you want to make sure that if you have your y value or your x value, that it corresponds to just one specific y value. Okay, let's look at Number 5, function notation. Okay, this is an example of an equation that does represent a function. Y equals 0.013x squared minus 0.21x plus 8.7. Okay, if I have an equation that I know is a function, I will use something called function notation, which here is f parenthesis x. This means f of x, or the function of x, and we write that in the place of the y. So I could take this same function. If I want to denote that it is a function, I will use this function notation in place of it. So again, that's not f times x, that means f of x, and it just lets you know that that equation represents a function.